recording. Okay, successive. The first meeting we are recording successively for programming. So we are to define methods with their formal parameters, then to invoke. To invoke is to call methods with actual parameters. Okay, those parameters are what we're calling the arguments. We would define what methods are with return value. Then we'll define methods without return value. We'll look at the difference between those two. Then we'll pass argument by methods. Arguments are basic and parameters. Then we'll develop reusable code. Okay, that is modular, easy to read, and to debug. Also to maintain. That is just talking about the importance of a method. A method is important. Number one, it is reusable. Number two, it is modular. Number three, it is easy to read, easy to debug, and easy to maintain. So we're gonna write a method that converts hexadecimal to decimal. This was a hot question days back, but it no longer comes. We use method overlapping and understand being ambiguous overlapping. Okay, we'll understand that at a later stage. We'll determine the scope variable. We'll talk about the scope, very, very important. We will try to apply the concept of a method abstraction in software development. That is also quite important, especially where your operating system is concerned. We'll design and implement methods using stepwise refinement. Hold on. Bola tayari amba kuma 1650. Na alafu mama mu class ngati yamba. Okay, so with that being said, we start by defining what a method is. So a method is basically a collection of statements that are grouped together to perform an operation. Okay, so of importance, I just hope you guys have somewhere to write. So we just give each other, we just give one another a minute, to at most a minute to get where to write, like we do, so that please get where to write, because we are to talk about methods, certain terms that are peculiar to our object-oriented programming. Because we'll come and say this is object-oriented programming, we talked about this, yet we didn't take that down. So please get where to write, and let me know once you prepare that. Have we gotten where to write? Have we gotten where to write?
Yes.
Okay, good. Um, okay. Um, this slide is quite important. So we would define a number of statements. Okay. So when we look at this public static int max max int num1 int num2. So first thing first to talk about here is this bracket we are seeing here, that and that. Okay, so that that there and that there. So this is what we are calling a method. Okay, this is what we are calling a method. Just after the word max, this bracket here. Okay, wherever we see this bracket is what we are calling a method. And there are a couple of statements that we have to consider here. One of those statements okay one of those statements is public. Okay, the term public is what we are okay, number one is access modifier. So let us start writing access modifier. Access modifier access modifier so by definition, an access modifier is a keyword. Access modifier is a keyword. Access modifier is a keyword which controls access modifier is a keyword which controls who can see and use a variable. Is a keyword which controls who can see and use a variable, comma, a message, comma, or a class. The terms that we are having are foundational to object-oriented programming. So an access modifier is a keyword which controls who can see which controls who can see and use a variable, comma, a method, comma, or a class. Did we get that? Did we get that?
Yes.
Good. So there are 4 access modifiers. There are 4 access modifiers. Very, very important. Please write that. There are 4 access modifiers. There are 4 access modifiers. There are 4 access modifiers. Number 1, public keyword. Number 1, public keyword. Number 1, a public keyword. Number 1, a public keyword. Number 2, number 2, give me a minute. Number 2, private keyword. Private keyword. Number 3, protected keyword. Number 3, protected keyword. Number 4, default / package. Number 4, default / package, so to speak. So we will define them later. For now, we just want to give analogy or examples. Please go ahead.
So you said public, private, protected, and
Default / package keyword. Default / package keyword. So we just want to quickly give examples of how to look at them. We just want to give examples of how to look at them. So think of a public. If you still can see my screen, there is this word here. Public is a keyword, okay, which control who can see and use a variable, a method, or a class. So this public, think of it like a phone number on a billboard. Everyone on a billboard can access that phone number. If they need to call it, they don't need permission to anyone. Private, it will start just like this. The public here will be written as private. Think of it as your mobile PIN or bank code. Only you can access that. That's protected. Okay? Oh, that is private, so to speak. Protected. Think of it as a fridge inside the house. Only family members can access that fridge. Someone can't come from 2 kilometers away from your house to come and open a fridge. Okay? Think of it as the University of Zambia Library. It can only be accessed by a person with a valid ID as long as they belong to UNZA. That is protected. Default. Think about it as you and the neighboring house. There are certain items that you can go to ask for from your neighbors, and your neighbors can come at your house. That is default. We will look at these terms at a later stage. We will look at these terms at a later stage. So, public is an access modifier. Very, very important. Okay? Then there's a word here, static. We'll look at static at a later stage. Okay? So the combination of this access modifier and a static, it is now called a modifier. Okay? What follows, even when there is no static here, there is only public int. What follows after this public, this is what we are calling a return type. A return type describes what is going to be returned. For example, when we say int, it means what we are going to have as an output is a number. When we say max, what we're going to have is the maximum of 2 or more items. Okay? And then there is this variable on int. Okay, so a return type, in most cases we'll refer to this in future as a type. Okay, so wherever we talk about the type, we're talking about return type. So when we are returning a value, if we want an output to be a value, that's where we can use these terms like int, double, float, and so on and so forth. This describes what we'll have as an output. That's quite important. So public, okay. We've written codes at some point that public static void main. Okay, if you remember that. Public static void main. You remember that, not so? Exactly. So the public and static, This is what we are calling a modifier. Okay? A modifier is different from access modifier. Access modifier is just a keyword. Now, a modifier determines the behavior, and we will look at this in object-oriented programming, because we will no longer be using the term static. So a modifier determines the behavior of the code. So this tells you how to access that code. Then how it is going to behave is the combination of these two. Then what comes here? Public static void. Here we had void. That is a return type. It describes the output. So if we are not returning a value, okay, we use the void here. But if we are returning a value, for example, a number, we can use int, double, float, and so on and so forth. So public static void main, where we have main was here. That's why we called it main method. So this is a method name. Okay? It is a method name. Then this bracket here is a method, wherever we see this. Okay? A method, by definition, this can be a bit challenging. A method, by definition, is the starting point, or is a point at which the code starts its execution. A method is a starting point, or a point at which the code starts its execution. And it is important to note that every Java code, not every code, every Java code has the main method. Very important. So main method is the combination of a method and a method name. So when we have main here, we are calling this main method. So here we have max method. Main as a method name. Main as a method name plus the method itself. A method is basically that bracket there. Okay? Now, in this method, we have what we are calling parameters. Or parameter list. They are just a list of items that are passed in that method. List of items passed in that method is what we are calling parameter list. Okay? Am I too fast? From the opening of a method to a closing of a method, those are parameter lists. Everything that you are going to see. Now, a parameter list consists of a type. Remember, when we talk about the type, is a return type, and the actual parameters. Okay? So return type and the actual parameter. return type, and the actual parameter. Those are parameter lists. These num1, num2, and so on and so forth, the variables except for the return type, the variables are what we call arguments. So when we talk about arguments, we are talking about the variables without their return types. Argument without their return type. Those are variables. Very important. Now, the combination of a parameter list and a return, method name, is what we are calling method signature. I remember Dr. Nerenda examined, testers. I don't know if it was quiz, either quizzed us or tested us on this. So a method signature is a combination of a method name and parameter list. That's very, very important to take note. Method signature. What's a method signature? It's a collection of a method name and parameter lists. That's quite important. Then we have the curly brace there. So we have the opening and the closing. We call this a block. Okay? We call this a block. This. Now, depending on where a block is going to be, when a block opens at the end of a method, it is called a method block. Okay? So you have a method there, then it opens here. This is a method block. And a method block contains the body. Okay? So this is the body of this method. And there are two types of blocks. There's a method block and a class block. If you remember, when you say public class name, you will use to open these. That is a class block. Now, a class block also contains the body. That's a classy body. That's very important. Now, the whole sentence here, the combination of a modifier, a return type, the method name, and the parameter list is what we are calling method header. It's a header, okay, just like the head. But this is a method, so we are calling it a method header. Method header. Okay, thank you. Are we good here? So, in this method body, we want the result. Then we have that guy there. Okay? If else statements. So we have num1 here, num2, and we are saying, okay, we want to keep this return type, which is an int, as the result. And how do we want it? If number 1 is greater than number 2, we get number 1 and assign it to the result. Else, we return number 2 and assign it to the result. Then we get the result. What we want at the end of this is what we are calling a return value. Are we good here? Are we good here? Okay, good. That's quite important to establish. So what you just have in the bracket there, here, that is the method signature, the combination of the method name and the parameter list. Then we have the actual value there, what we are calling arguments or parameters themselves, or actual parameters or formal parameters, which is that x and y. So this can be x, this can be y, which is that point there. Okay. So calling a method, if you remember, in our objectives, we talked about invoking. To invoke a method is to call that method. So how do we call a method? Look at this. We have the access modifier. The access modifier plus a static keyword, they are called modifiers. We have a void. This is a return type. Okay? Then this is the method name. Then those are arguments passed there. So we have a method block. We declare some values here. 5 assigns to 1, 2 assigned to j. Then we want the maximum of I and j, then assign to k. Okay? So now, if we want to call this, what is going to happen? Watch. So I is 5, which we've said there. J is 2. Then we want the maximum invoke. That means call. We want to call the maximum of 1 and 2. Because that is a method there, which we want to call. So what is going to happen? We want now to get a value, and we are saying the maximum. So what is going to happen? num1, num2, and of these integers, we are going to initialize the result, so that when we get any of these numbers, we keep them in that result there as an int. Then among those two numbers, number 1 and number 2, we say if number 1 is greater than number 2, okay? If number 1 is greater than number 2, which one do you think we are going to get? Is it number 1 or number 2? One. So we will get the number 1 and assign it to the result, because we want to keep it in that result there. So number 1 is assigned to the result. If that is not the case, it means number 2 is greater. So we are going to assign number to the result, then return the result as either number 1 or number 2. So this is what is going to happen. So after reaching here, we are going to return the result. Now we go back to I and j. So the I is 5, j is 2. So we are now going to print k, because number 1, which is true, number 1, the first value is assigned to number 1, the second value is assigned to number 2, and number 1 is 5, so 5 will be assigned to the result, and the moment it is assigned to the result, because it is true, the result will become 5, and will return that 5 there, and that 5, please give me a minute. Alo, wewe na wale tuma panse wale tumi 9. Mwewe nsevi wale tumi 9. Ndini. That's what is going to happen. Okay, so in a method, a return statement is mandatory for value returning method. What do we mean? Remember, so when a method, this is a method name, but this is a return type here. So when we have a int here, okay, it means we are returning a value. We are not using void. As long as the return type here is not a void, it means we are returning a value. In that instance, a return keyword is necessary. So you have to use the keyword return, because at this point the return type is not a void. Remember, if you say public static void, at this instance you are not returning a value. As long as it's not a void, it means you are returning a value. So a return keyword is necessary. That's what they mean. That's what they mean here. So a return statement is required for a value returning method. Are we good there? Are we good there? Tairamba bora. Oh. Okay, so that is quite necessary. So here return type is int, therefore a return statement is necessary. Remember, a semicolon is a statement terminator. Okay, so one of the advantages of a method is we can write that method once and use it throughout. So a method is reusable. Note, one of the benefits of a method is for reuse. That means you can write a method once and refer to that method. That's why you can revoke. It means you can call that method repeatedly. Okay? The max method, for example, and so on and so forth. Okay, this is a stack, quite important, but you look at this in your third year. You have math in your first semester, which you are going to look at that and how things are flowing there. No one is going to ask you about that. Let us not just dwell too much on that. Otherwise, there's a very nice explanation there. Please don't bother. No one is going to ask you about cost stack, trace stack. This is third year. Don't worry about those. Passing a parameter, so public static void, so we are not returning a value. N print ln message whatever, not so important. Not so important to be emphasizing. Modularizing, not so important. We will try by all means picking what is important so that we make the progress. Overloading a method. Okay, we can say something here, but this will come in your object-oriented programming, where we are going to differentiate method overloading and method overriding, and the reasons for overloading and the reasons for overriding. This is very examinable. Method overloading, method overriding. Okay, let us just make a progress. We will come to this in object-oriented programming. Very important. And because innovation not so important. Okay, scope of a variable. This we can talk about. So scope of a variable, a scope is, give me a minute. Okay, thank you for that. I hope you're still in the meeting. Okay, so a scope of a variable, very important, you can take note of that. A scope of a variable okay, a scope of a variable describes a scope of a variable describes where that variable is allowed to be accessed or to be used. A good example, if they say in your house, there are certain items that does not require to leave the bedroom. there are a lot of items that are not required to leave the bedroom. Those items are allowed or can only be used in that bedroom. It's basically a space where those items are allowed to be used. You cannot get a sponge that you use in the bathroom and take it in the sitting room. That sponge is not allowed to be used in either a TV room, sitting room, living room that is designed for a bathroom. In the same way, a scope of a variable describes where that variable is allowed to be used or to be accessed. That is very, very important. Okay? And there are two types of scope variable. There are two types of scope variable. Number one, global variable. Number two, local variable. Just a bonus, when you go in possibly fourth year, you are going to look at what they call a method variable. But at this stage, we just look at global variable and method variable. Good example. Okay. Good example. So this is a block here, which is a method block, and we have variables here such as I, j, k. These are variables. So these variables cannot be accessed outside this method block. This is the scope of these variables. There are variables that can be defined at the top there. They are called global variables. We are going to look at this in object-oriented programming. For now, this is just the foundation, which is very, very, very necessary. Did we get that well?
We hope you enjoyed your stay at the Royal Gate Hotel.
Did we get that well?
So we should go to lunch. Through the lobby. Past the doorman.
Okay, good. So let's say public static void method there. There's a method name here. There's a block here. Okay. So you see this this block opens there, it closes there. So there are these variables inside this block here. So this is the scope of this is a scope. There is this opening here as well, this opening here as well. So there is these between this and that. So this is also a scope there. Okay, that's quite important. Okay, so scope of local variable. We said there are two types of variables. There is a local variable and global variable. Don't worry about those. We'll talk about that at the point of object-oriented programming. For now, we have to make the progress. We are just introducing those terms to you. Okay. Fine with no error. These will make sense in object-oriented programming. Don't worry. Method abstraction. Okay. If you remember, we talked about what a method header is. Okay. When we have a method like this, so public static void main there, this is a method header. So again, these are some of the terms that we are going to be looking at in object-oriented programming, such as abstraction and so on and so forth. Okay, so abstraction just means you can't directly access it. It's more like you can't use a kitchen directly unless you open a door. Okay, as long as you don't open a door, you can't access a kitchen. In the same way, method abstraction is basically saying, okay, we have, for example, a method header there. Then for you to access the method body, you need to pass through the method header. So the method body is blocked. Okay, so it is blocked from you. You can't see it. Benefits of a method, of methods. Okay, so you write a method once and they reuse it anywhere. That is, it allows the reuse. Information hiding, that is abstraction we are talking about. That is abstraction there. For example, you can't access what is inside here without passing through that. So you need to pass through that, then you enter inside here. That's when you can access that. So this is hidden from you, so it gives a form of protection. That's what we're saying. So information is protected. That means hide the implementation from the user and reduces complexity. General characteristics of a random character, not so important. Okay, you're welcome. Random character, not so important. I think at some point we have looked at what those means. Okay, the 0 to 9, the A to Z, the Unicode. I don't know if you remember that. Do you remember the Unicode? I see. Okay. So that is just a start case. It's not important. Not important. Print calendar. Not so important.
Kelly's predilections and his predation were never a secret.
Did we lose you?
People knew of his behavior.
Okay. Design diagram, print calendar, not so important. Please, whatever we are saying not important, don't pay attention to them. No one will examine you on that. Your exam will be full of object-oriented programming. No wonder we want to push, we want to ensure that we finish this foundation. Methods, single dimension, 2-dimension, and so on and so forth. This week we just do with the programming, so that the next time we talk about the programming, we introduce that concept of object-oriented programming. That is very, very important. We start having confidence for this course. Benefits of stepwise redefinement, not so important. No one will examine you on that. So this is the end of this meeting. Please just rewatch the video so that you are acquainted with what we've just talked about. You know where to concentrate. Unless you have a question. Okay. We are free to sign out, and we see each other on Wednesday and on Friday, so that we finish up this general programming. And going forward, we will never use with object-oriented programming. We will never use Dr. Narenda's notes. Never. I just finished preparing object-oriented programming in the best way possible. Alright, you're free to sign out and have a good evening.